I know the rain's good for us, but when I feel like I'm fucking gonna wipe out when I'm driving, fucking drive through unseen water. That fucking sucks. And today is the first day my fucking solar has permission to operate. They want to turn it on and it's fucking not gonna do a goddamn thing today. Fucking good times. All right, what lecture day are we on here? 5, 4? I know, I can just check Canvas. I hate fucking labeling these wrong and then I'm trying to put up the videos later on with a name. Let's see. Four. And math 335, I'm lazy enough that I don't want to write math, so I just put M. Lecture day 4. We are going to prep for R6, which is on radicals and rational exponents. So this is where we get our good old square root sign. We didn't even have a letter in here, a number in front. So this crazy symbol right here is called the radical symbol. This is called the radicand. And I tend to actually use that word because I know I like to avoid math jargon, but like the alternative is the thing under the square root sign, which takes a hell of a lot longer to say than radicand. So get you used to it. The n here is called the index. And when, if n equals 2, we don't show it. This is the same as this. And we tend to, you kind of want to put a little ledge there. The index sits on the ledge. Not everybody does this little tail portion right here. I do this like a little tail hanging over, or an eve like on a roof. The idea is it says when the radical, where the radical ends. It's good notation to get used to. Now, I'm pretty sure we looked at rules of exponents before. No, we didn't. Not really. It's like I need to first do that real quick. This is also the equivalent of saying 64 to the 1/2 power. So these are the same thing. Well, what's the square root sign mean? Does anyone not know what the square root is?
It's like what you multiply by itself to get that number.
It's kind of hard to put into words, right? But that's what it is. What multiplies by itself to get the number inside? And we know that this here would be 8. How does this connect to the exponent that I did here, 64 to the 1/2? If I say 64 to the 1/2 equals x, and I don't know what x is, but we know it's 8, but we're gonna show that we get 8. Some rules of exponents are I can square both sides. And when you have x to the m to the nth power like we do here, this is equivalent to x to the m times n. Which means this is 64 to the 1/2 times 2, which is 1/2 times 2 is just 1, right? That's just 64. And the right side is x squared. And now we see that expression right here. What multiplies by itself, that's what squaring means. What multiplies by itself to get the number inside. So you just, when you start with x squared equals 64, you can just take the square roots of both sides and you get x equals 8. And the first, I don't know, 13 square roots aren't that bad. So the perfect squares. So I'm writing the squares below it. Maybe I should separate these with commas so they don't look like they're the same number. Touching. 7 is 49, 8 is 64, 9 is 81, 10 is 100. That's 121, and this is called a gross 144. That's a name. That one's got a fucking name. 12 times 12 is a gross. What? I fucking don't know. I don't know why they bothered naming that one. I'm sure, absolutely sure it has to do with manufacturing and production and shit like that. And so this is squares going this way, so the other direction is square roots. So we say the index with the 2, we call that a square root because it's related to the square. And we generally, again, don't show the square root sign, or that we don't show the 2. That's very much related to a square. S times S, it's really like the area of a square is S squared. The next one we have a name for is the one with 3, and that one we do need to show. And this is called a cube root because it's related to the volume of a cube. Am I sharing screen? Oh, yeah, okay, good. I'm not sharing it over here. So let's try this again. Fuck. For those of you that missed the first part and watching on video, that's the first page. Pause it, write it down. There's a second page, pause it, write it down, and then you're caught up with this. Okay. After that, the index, whatever that number is, and like say this, we just say it's the fifth root. We start using kind of like street signs. The numbers are treated like street signs. Fifth Avenue, fifth root. Guys ready for some more? I'm certain you've all seen the roots before. Whether it's been a while or not, I don't know. Whether you've seen them written as the exponents is something else. So I said that this was the same as 1/2. I'm going to take this a little bit further and show you a general form, because that's what we're going to do in the main class. So if I have the nth root of x to the m, this can be written as x to the m over n. And this is the same thing as x to the m times 1 over n, which is also x to the 1 over n times m. I can break it up like that. This manipulation of this fraction and this number really gives us a lot, because that's the same as x to the m to the 1 over n, which is the same thing as what I wrote there, nth root of x over m. This one, though, this one reads x to the 1 over n to the mth power, which means the square root to the nth power of x raised to the n power. These are identical. And they all equal the fractional. There's some examples actually for you guys to play with. So we're going to do rewrite as exponents, or using exponents. Let's do a is cube root of 8. B will be the fifth root of x squared. What else should I throw at you guys? fifth root of 16. And we'll compare that to the fifth root of 32. This is the first semester that the students emailed my personal email to say they were going to be absent for the day. Now, oh shit. So much enough. Yeah, they don't even really I don't take rolls, so it's. All right, so how would we rewrite the cube root of 8 with exponents? Anybody got an idea?
Is it 8 to the power of 1/3?
It is. We said use the exponent on the inside to put on top, but when we don't have an exponent, that's the same thing as 8 to the first power. So it's a little sneaky. What about the fifth root of x squared?
X to the 2/5 power.
2/5 power?
Is that how you say it? Or how do you say it?
That works. If you want to say it's a fraction, it would be 2/5.
X to the 2/5 power.
About 16. I did 5 on one of these, didn't I? Not a lot of variety here. 1/5, that's good. About this one.
32.
All right, so that's how we write them as exponents. Now, some of these simplify more. So when we talk about simplifying this stuff, simplifying these. When we have them written as like 8 to the 1/3, that's the exponent. You've heard me say, but this is called the base. I don't know that I've identified that as the base yet, but I'm going to reference it here. Simplifying these generally has converting the base to prime numbers can help simplify. Hey, going well. So what I mean by this, let's just look at our 8 to the 1/3. I'm gonna put the 8 in parentheses. 8 is 2 times 2 times 2. Those are the prime numbers. Like any number that can only be multiplied by itself and 1 to get the number is a prime number. So this is 2 cubed to the 1/3 power. Because that's what exponents mean, repeated multiplication. And now I can multiply that, the exponents. And I just get 2 to the first power of 2. So the 8 to the 1/3 actually simplifies to a common number. So one way of finding the prime numbers, I'd like race through the 8, but didn't like show you how to do it. I'll show you with the 32. Let's take a look at the 32 to the 1/5 power. I want to, it's called a prime factorization. We talked about doing this on the polynomial stuff the other day. Just pick 2 numbers that multiply and make it. What 2 numbers do you guys think of when you think of to multiply to make 32?
16, 2.
16 and 2 works. That's usually not the ones people think of. Because it's not on your base 10 by 10 times table, but it works. 2 is a prime number. What about 16? Does it break down further? Can I divide it by any number? Yeah, this turns into a 4 times 4. Can I break down a 4? 4 breaks down to a 2. And 2 is prime. And so I have 1, 2, 3, 4, 5 2s in there. This is 2 to the 5th power.
This may sound like a stupid question, but what is a prime number again?
Nothing stupid about that question. Prime numbers. The only way to get these. Through multiplication. Fuck. Is by multiplying themselves and 1. Original number and 1. For example, 2.
3, 5, 7.
Yes. 2, 3, 5, 7. 11 is the next one. 13.
17.
17 is the next one.
19.
19 is a prime.
Go all
Now, there's something really neat. You guys will like this. Let me bring it up. Steve, what is that? Eratosthenes. Okay, let's show you guys. Oh. So what they're doing is they start with the first number 2, and this is a 10 by 12 table, and they block off every number, every second number. And when they get to the bottom, then they're gonna go to the next uncolored number and color that one out, because it's prime. So 2 is prime, and they're crossing out all the rest. The coloring is bad. They show the prime number 2 on the left. Then they're gonna do 3, and then they're gonna go to every third number and cross it off. So they're doing that with the green now. 3 shows up and they're crossing off every third number.
Yeah, we can't see. this.
Son of a bitch. Let's try that. Let me refresh. So they mark down 2, the first number, and they start crossing off all the other numbers. They should just cross them off. I don't know why they're fucking doing it, lighter shade here.
So it'd be like multiples.
Yeah, all the multiples of 2. Every second number or anything that's a multiple of 2. Then when they get through it, they're gonna do 3s. And every multiple of 3, and there's overlap, like 6 is a multiple of 3 and 2. But if it's already crossed off, it doesn't matter, you can cross it off again. And as you go along, the next unblocked or uncolored number is prime. So when it gets through this, 5 will be the next prime. And we can already see, James had said 2, 3, 5, 7, 11, 13, 17, 19 are already, we're already got the first primes out of 20 just by crossing off multiples of 2 and 3. But it goes through and generates them that way. It's kind of neat. And now the rest are gonna be prime because there's no way the multiple appears on the table below. Once you get past the halfway point, there's no way. Like it's going to 120. Once you get past 60, 61 or higher, if I multiply by 2, I'm gonna pass the 120. It's gonna be past it. It's called the sieve of Eratosthenes.
My gosh.
I don't know where he got like fucking computer screen to do this on, but
Yeah, I know. Well, I mean, you probably just break the dirt.
right?
It's just like, oh, cross that one out.
It's come on, it works.
Yeah, it works.
Okay. So. Let's come back to, that's what prime numbers are. That answers your question.
Got it.
And really memorizing, you kind of know them. Because if you know the multiplication of the 10 by 10, or if you have your multiplication table for 10 by 10 memorized, you know them because none of them, they show up anywhere. Every once in a while, one is not on there. Like 39 doesn't show up on the multiplication table, but it's 3 times 13. There's a couple of them on there that aren't on the 10 by 10, but most of them, if it's a product in the multiplication table, it's not prime. I forget what they call a non-prime word.
It's like,
Compound number or something fucking stupid.
Yes.
I don't remember, yeah, I think it's composite.
Composite. I knew it had a comp in it. Compound didn't sound right. It's called a composite number. So composite numbers are non-primes is really. And there is, of course, the one number, countable number that doesn't get a fucking name. 1 is not prime nor composite. I don't think it counts as a composite. Well, it's not a composite because it's not made up of 2 different numbers. But 1 you can technically get by doing 1 times 1, which is the same thing as just saying 2 times 1 or 3 times 1, but they don't count 1 as prime. So the primes start at 2. I have no idea. No respect for the number 1. It is just a fucking jealousy. That's what it is. All those other little bitches are like, we're not number one, so fuck number one. Cause if you're not first place, what's second place? What's the other name for second place? First loser, right? You're still a fucking loser. You didn't win. They need to teach that to kids rather than handing out fucking participation prizes. Second place, that's a fucking lesson for life, because that's how the world works. You get to the world, if you're not doing the best, they'll fucking fire you and replace you with someone that does a better job. You basically don't have to be the best if there's more than one position available. But like if there's 20 positions, you want to kind of be in the top 20. The 21st position, you might get axed. So yeah, they don't teach that to kids, unfortunately. So let's keep going with this. So we had our rules for our radicals. And with all the shifting around the exponents, we can do more with it. And we're gonna do all this again in the next hour. But if I have the nth root of A and I multiply by the nth root of B, we can put those together and make the nth root of A times B. Yeah.
If specifically in this, if A and B, let's say if the nth root of B was also B and B squared was inside B. Do we carry that through or should we reduce it first?
As long as it's reduced by the end, you're good to go.
So like if.
I'll show you an example right now.
Yeah,
I'll show several examples right now. That might answer your question. So square root of 2 times square root of 2. One way of doing this is saying this is square root of 2 times 2, which is square root of 4. And hopefully you know that's 2. But the other way of looking at this is the square root of 2 squared. And square roots and squares cancel. And that applies to anything where I can remove the word square. Cube roots and cubes cancel. Fourth roots and fourth powers cancel. Nth roots and nth powers cancel. So that would just be 2. If we turn that into that using the fractions, this is 2 squared to the 1/2. And then we see by multiplying the fractions, we get 2 times 1/2, which is 2 to the first power, which is 2. It's a lot of work, right? But I'm just like writing this to be clear. You will, if once you're comfortable with how the multiplication is going, you'll bypass a bunch of this shit. I wouldn't write to the first. I wouldn't even write this step.
so then you can have, so let's say we haven't gotten an I yet, but I'm like.
We're doing it today.
Yeah, I was gonna say we're there today, and I'm like, because I'm seeing roots, but I'm like, I to the second would be.
Close. It's a -1.
Yeah.
We'll do that today. We're just getting through the working with the radicals here.
And next week we'll be in the regular meat of the course, right? We're done with the review.
Yeah.
We're supposed to be.
Yeah. And I'm sure you've actually seen a bunch of the stuff in the regular course too. It's all algebra stuff, but we're gonna try to elevate it. So where else does this kind of help us? Well, if I've got like the square root of 6 times the square root of 12.
Down in the parts.
We have a couple options. We can do 6 times 12 and make this 72. I don't know that that's a helpful approach. It's not bad with 72. Because a lot of people know that what two numbers multiply to make 72 from the times table. But in general, you're better off starting with factoring these. This is 2 times 3. This is 4 times 3 and 2 times 2. So when I put them together, I have got 3 2s and 2 3s. Yeah, just like I put them together through multiplication, I can go the other direction and yank this shit apart. This can be yanked apart into the square root of 3 squared times the square root of 2 cubed. And I can go even further. Well, first off, let's just address what this is. What is the square root of 3 squared? 3. Now, this is 2 squared, 2 like that, 2 to the 2 plus 1, which is really 2 squared times 2 to the first. Those two are identical, other than the square root. And I can split that sumbitch up. And I won't put the exponent 1 here. And the square root of 2 squared is 2. So I've got 3 times 2 times the square root of 2. Which ends up just being 6 times the square root of 2. Which is how we would write it. This would be the simplified form. No, no, no. Square root of 2, 6. Don't look like you're an idiot. Some languages actually put like the adjectives afterwards, but in English and in mathematics, we put them before. Just like we say 2x and not x2. We say 2 cars, not cars 2.
What's it cars? Sorry.
My wife and own cars 2. What the fuck? This is my wife and I own 2 cars. That makes sense. Depending on the language though, sometimes the noun comes first, followed by the adjectives. But mathematics is like that, and pretty much anything that's not a number, like a symbol, you're gonna want to put like the whole numbers in front of it. Now, there's another way to do this a little bit quicker. But breaking down the primes always works. Since I can recognize 12 is 6 times 2, I can stop there and do this. And I'm really just showing how to work spelling it out. I'm breaking it into that. So that I have square root of 6 squared times square root of 2. And then this is 6 square root of 2. Because the squares and square roots cancel.
Could it be said that a lot of what we're learning right now, a lot of the review, all this is so that we can know how, so we can understand how bigger.
Yep.
That's really what all this is about.
Yeah.
It's because if we don't know this part first, we don't know what to do with those equations, even though these are not the equations necessarily.
They're components of shit you'll use later on.
Yeah. It's not necessarily that we're gonna use like absolute value and like linear analysis, but
No, but there are real life applications of the absolute values. Like I think we were talking about the other day, where it's a lot of them are what's the fucking stats description?
Margin of error.
Margin of error, that's exactly the word for it. Margin of error in temperature when you're healthy versus sick is a couple degrees. And you can do it with, you can model it using absolute value. Margin of error in a lot of things. Square roots show up because it's the opposite of squares, and we have a lot of square shit. Oddly enough, in real life. A lot of it's related to area and volume for the most part, but there are other applications. Area and volume are easy when you're picturing squares and cubes and rectangles and boxes and shit like that. The formulas are more complicated for things like spheres and cones, but they're doable. But then what about if fucking it's just a fucking graph shape and you want the area underneath that fucking graph between the bottom of the graph? That's what calculus gets you. Calculus is finding the area beneath the curve, which has a lot of real life applications. All right, more review stuff. I was using numbers there, but this also applies to using letters. I'll do cube root this time. I could put that together to make cube root of x squared times x to the 8. And I mentioned that earlier, showed a little bit earlier. That is the same thing as, oops, x to the 2 plus 8. If you've forgotten why, I will show you real quick as a reminder. X squared is x times x. X to the 8, I wish I hadn't said I'd show you right now. That's a lot of fucking x's, right? And if I multiply them together, there are 10 x's. So that becomes the x one. So this is the cube root of x to the 10th power. The slow way, until you're comfortable going faster, is keep peeling off x's to the power of 3 until you can't go down anymore. So we start at 10. 10 minus 3 is 7. I can go down more. 7 minus 3 is 4. That gives me, this is my second 3. 4 minus 3 is 1. That gives me a third 3. And I can't go down any further, so I got an x to the first. And each one of these, I could do this. This is a really long, fucking tedious way of doing it. But I think you can see that we end up getting an x for the first one, an x for the second one, an x for the third one, and we end up getting x cubed times the cube root of x. That is what that will end up being. Let's show that in a lot fucking easier form. A lot of people really want to, that will fucking go the long road to do this, using this radical idea every fucking time, rather than switching to rational exponents, fractions and the exponents. Because the fractions make it really fucking easy. I'm gonna go back to that cube root of x to the 10th power. This can be rewritten as what? We covered this earlier.
X to the 10 over 3.
10 over 3. If I divide 10 by 3, I get 3 with one remainder. So I get 3 1/3. Three and 1/3 really means 3 plus 1/3. We don't show the plus, but it fucking, and you don't need to show the plus. The only reason I'm doing it is because we saw plus can be pulled apart. I can make it two different things. This is x cubed times x to the 1/3. And now x cubed root of x. If you're good with doing basic writing fractions as mixed numbers, you go from there to there really fucking quickly. Because I only wrote out this stuff to like spell out what I was doing. When you're teaching shit, you've gotta write down more than you would actually write when you're comfortable doing it. This is the equivalent of leaving in the radicals is going cube root of x to the 10th equals cube root of x to the 9th times x. And then going the 9 is divisible by 3, I'm gonna pull that out. And that just gives me x cubed, cube root of x.
Is there any calculation, like if I just had a root x, like or just regular root x?
Unless you know what x is, you can't do a goddamn thing.
Stuck.
Because at this point, it's an unknown quantity.
Because I can't, if there's an equal sign, that's something else, I have to square that thing. Out. If it was like a complex thing, like it's like a bunch of different numbers and values, whatever, I'd have to square the entire thing on the other side.
We're gonna cover solving equations with these today also. There's a lot of shit going on today with this stuff. I know, shake that head, everyone's like, fuck this, I'm out. Peace. All right, so. I'm gonna show you because I put it up and I don't know how many people look at it. I put links to last spring's videos where these are like, most of these are 2-hour videos. This one's on factoring, more with like 2 parts of factoring. Rational expressions is what we were doing at the end of Tuesday. We're gonna do a little bit more today before we dive into radicals. And what I'm doing right now, this is effectively 6 hours worth of going really slowly through this, working through a bunch of different examples. And yeah, it was too much. I was trying to teach this class like, because it was coming straight out of the pandemic. And I was getting students that didn't know fucking shit. Students, they're getting passed. They were getting passed from all their classes, whether they fucking passed their classes. So it says I passed my algebra course. I'm fucking, I guess I don't need algebra no more. No, just because you got a passing grade doesn't mean you know it. So I had to redo a lot of stuff. But those are videos you can watch. They're all links to YouTube videos. Pause, yeah, they're all long, but fucking pause them. Or fast forward through them. If you're like, I know this shit, go to the click in 5-minute increments so you see something you don't recognize how to do. I'm gonna hit stop record here while we wait for the next class to start.